Now let's turn to another kind of sequential game. Now, there are some games that are in this repeated kind of setup that we've talked about before. Now, this type of game is a little bit different. Here, each player has a little bit different option, and I think most games are used to actually follow more this structure than the one we've talked about. For example, in chess, after I move my piece, that changes the options that are available to the other player. So it's actually much closer to what we're talking about here. So here we have two players in the traditional what we call an ultimatum game. So player one gets to decide how they're going to split $1. They come up with some offer of some way to split it. They can split it 50-50, 99 cents for me, 1 cent for you, and so on. Player 2 then gets to either accept or reject that offer. If player 2 accepts, then the dollar is split as the two agreed. If, however, player 2 rejects, then both players walk away with nothing, and the game is over. Right, so player 2 either accepts that offer or gets nothing at all. Right, that's why it's an ultimatum. So let's think about, using backward induction, how this game would be solved. Backward induction, we start with the end of the game. So we start with player 2. Right, player 2 is going to have a rule where they're going to accept the offer as long as it's better than rejecting. Well, that really just means they'll accept as long as they get at least a penny, right? Because a penny is better than nothing. Now here, an important point is that we're assuming that player 2 really only cares about the amount of money they have. They don't so much care about things like fairness or that sort of thing. So it doesn't really bother me if I'm getting quote-unquote ripped off, as long as I'm better off than if I didn't get ripped at all, I guess. Okay, so player 2 is going to accept as long as they get at least a penny. Then player 1, as they're thinking about this game, is going to say, well, I know player 2 will accept as long as they get at least a penny, because a penny is better than nothing. So I'm going to offer them a penny and keep 99 cents for myself. Once again, player 1 just cares about how much money they get to keep for themselves. They don't care about fairness and the like. So player 1 says, here's a penny, I'll keep 99 cents, what do you think? And player 2 accepts. And that's the way that things get divided. Now, an important point here is that when we actually have people play this game, this very, very rarely happens. Instead, it's much more common. The most common thing, I believe, is for player 1 to do something like split things 60-40. Right, so 60 for themselves, 40 for the other person. That tends to be accepted. It tends to be that if you get much worse than, say, 75-25, something in that range, 75-25, 80-20, anything worse than that, player 2 starts to reject, despite the fact that means they walk away with nothing. Right, so why is that? Well, now, we already have some hint at that, and that people do actually care about fairness. Right? Fairness does have some kind of price attached to it, so if there's some kind of outcome that's horribly unfair, we tend not to be willing to go for it. We'd rather, in fact, hurt ourselves, even if it means as long as it means hurting the other person more. In effect, we want to punish them for being a jerk. It's really what it comes down to. And this is something we value and are willing to make ourselves financially worse off in order to make this kind of moral point. Right, so it is important to keep that in mind, that people do care about things beyond money, which might mean that backward induction applied in the wrong way might lead us astray. Okay, so just keep that in mind. So we're going to have to make the assumption that the things that we are taking account of whenever we do game theory are the things that people actually care about. So we got the right ranking down. Now, one thing that I do find very interesting about this kind of experiment is that it does seem that fairness has a price. So if you're taking a small sum of money, say $100, and having two Americans figure out how to split it, it'll get split very close to 50-50, and you will see a lot of willingness for player 2s to punish player 1 if they give something that's really unequal. But if you scale up the amount of money that's being split to, say, something like $1 million or $10 million or $1 billion, suddenly people are much more likely to split this thing very, very unevenly, and people are willing to accept very uneven splits. The way that they proved this, rather than having Americans and trying to give them millions of dollars, which would naturally be very expensive, they went into relatively poor villages in India and found that there, with a relatively small amount of American money, which is a lot once you adjust for standard of living and the like, with relatively small amounts of American money, these look like large sums to the people they were working with. And with that, we tended to see very unequal distributions being offered, and we tended to see them being accepted. So it's very close to what backward induction would suggest. We just have to get over, in effect, the price of fairness. so that people are willing to accept these unfair outcomes. Okay, so then let's turn to other applications. Right. This is another application where what would I call charity clinics. First, let's think about this as a simultaneous game. So here we have the rich and the poor. The rich can either pay for a vaccine for the poor to take or not pay for it. The poor then have the choice of either taking the vaccine or not. Now, if we think of this as a simultaneous game where each of them is playing, not quite sure what the other player is going to do, we can walk through and find a Nash equilibrium. Right, so the rich says, if the poor take the vaccine, I consider myself to have no control over that. In that case, well, I'm not going to pay for it. Right, they've already provided any benefit, right? Because I would like to see this disease eradicated, but I'd much rather see it eradicated and not have to pay for it myself. So as long as the poor are going to take the vaccine, there's no point in the rich paying for it. And then the rich say, well, if the poor aren't going to take the vaccine, well then once again, there's still no point in me paying for it. That would just be a pure waste of money. Right? Then the poor say, well, if the rich pay for the vaccine, it's worth taking. In fact, that's the best outcome as far as the poor are concerned, because they have their money to spend on things like food, but at the same time they're protected against disease. Now, if the rich don't pay for the vaccine, the poor don't want to take it. Right, so, because after all, they want to keep their money for things like food, things that are definitely things they need, whereas the vaccine is only protecting against the possibility of a disease. Right? So when we go looking for a Nash equilibrium, we find that in the simultaneous game, the rich will not pay for the vaccine, and the poor will not take the vaccine. After all, what's going to happen here is the rich say, it doesn't matter what the poor do, we're not paying. The poor say, well, odds are good the rich aren't going to pay, so we're not going to take the vaccine. That's the world we end up in. Despite the fact that both rich and poor would rather live in a world where the rich pay for the vaccine and the poor take it. Right? The rich do value eliminating the disease enough to pay for the vaccine as long as they could guarantee the poor would take it. But here, because they don't consider themselves to have any control over the poor, they're acting simultaneously, we can't get that to happen. Moving this then to a sequential game might make a difference. So let's think of it this way. Let's suppose the rich act first. Right? They either pay or they don't pay. So this is what we call a game tree. The game is played from left to right, and we follow various branches. So the rich can either pay for the vaccine or not pay for it. And the poor can either take the vaccine or not, and they get the payoffs that you see here on the edge. It's really just those payoffs from the simultaneous game, but written down in the proper order here. Right? So the way the rich are going to reason is say, well, if I pay for it, what will the poor do? The poor can either take the vaccine or not. If they take it, they get 4. That's their best possible world. If they don't take it, they get 3. Well, in that case, if the rich pay, the poor are going to take the vaccine. That's a sensible result. And then the rich say, well, if we don't pay for it, what will the poor do in response? Right? In response, we know the poor will not pay for a vaccine if they have to pay for it themselves, so they're not going to take it. Now, knowing these responses, the rich will then say, well, I know if I pay for it, the poor take the vaccine. If I don't pay for it, the poor won't take the vaccine. So in that case, the rich find some way to credibly commit to paying for this vaccine. So they might do something like setting up these charity clinics, where the poor can observe, yes, these charity clinics are here, they're in operation, they say they're going to give us free vaccines, you go, you get vaccinated. Right? So this is one way a sequential game could play out. Now for this to work, it needs to be that one player plays first, in this case the rich plays first, they are observed, so the poor can observe that the rich are in fact paying for these vaccines, right, and then respond. Right? So that's the way this all would tend to work out in this charity clinic case with a sequence. Now an important thing about the sequential game, though, is that it's important not only that it is sequential, but that the sequence is a particular sequence. Right? So let's think about that. What if the poor made their decision first? So either take the vaccine or don't, and then it's up to the poor to try to convince the rich to pay for it or not. Well, in that case, if the poor take the vaccine and then go to the rich say, well, you've already taken the vaccine, there's no point in me paying for it. If the poor don't take the vaccine and then go to the rich and ask them to hand them money, the rich say, well, I see that you didn't take the vaccine, I'm not just going to hand you money for no reason. So in either case, the rich are not going to pay for the vaccine. The poor, knowing that, would say, well, I'd much rather save my food for something else, I'm not going to take the vaccine. And so here we have the totally opposite outcome if we change the order. So if the poor act first, we don't get any charity clinics set up, the poor don't get vaccinated. If the rich act first, then we do get charity clinics set up, and the poor do get vaccinated. So the sequence matters. Another case would be an entry game. So here we have a case where we have an incumbent firm. The incumbent firm is something of a monopoly right now. They have the choice of either charging a high price or a low price. But at the same time, they're not a protected monopoly. So there is the potential for some entrant to come in and to try to compete with this monopoly. Right, so the entrant has the choice of either entering or not. After they make that choice, here the incumbent chooses either a high price or a low price, with the profits as listed across the right. If the entrant enters, they say, well, in that case the incumbent could charge a high price or a low price. Well, with a high price, they're not going to be able to compete with the entrant, so the incumbent would take a loss. At a low price, the incumbent has the structure there to fight off this entrant, and so they would make a small profit. Knowing that, the entrant would say, well, if I enter, the incumbent's going to try to charge a low price. On the other hand, if I as the entrant don't enter, the incumbent will charge a high price, earning themselves a higher profit. They don't have to worry about competition there. That's much better than charging a low price if they don't have to worry about competition. Okay. So here we have the entrant could enter or not. If they enter, the incumbent will charge a low price. The entrant knows that they can't really compete with that. They'd end up taking a loss. Or the entrant could not enter and not worry about taking a loss. In this case, not entering is the better option. So we end up seeing the game play out this way. The entrant decides not to enter, at which point the incumbent firm decides to charge a high price. So in this case, at the end of the game, we have the monopoly. It started out as a monopoly. It ends up as a monopoly. There's no competition with it. And it's acting like a monopoly. It's charging a high price for its product. But what happens if we reverse the order? Suppose the incumbent has to choose their price first, then the entrant can respond by either entering or not. Well, in this case, if the incumbent charges a high price, the entrant says, well, I can compete with that, and goes ahead and enters. Right. Meanwhile, if the incumbent charges a low price, the entrant says, well, I can't compete with a low price, so I'm not going to bother entering. I'd rather not enter than take a loss. Well, knowing this, the incumbent would say, if I charge a high price, I'm going to be drawing in this competition. I don't want that. That's bad for me. If I charge a low price, I'm going to keep competition at bay. Well, that's a good thing for me. I'd rather not have competition than have to face this competition and perhaps take losses. Right, so the incumbent firm says, let's charge a low price. This is what we call virtual competition. Here, it's true, we have a monopoly at the beginning of the game, and it's still a monopoly at the end. There is no competition in there. But at the same time, that monopoly is acting competitive, that it is charging a low price for its product. Right? So it's as if the incumbent firm is trying to fight off competitors, even though there aren't any competitors in there. That's why we call it virtual competition. These competitors are not real in the sense they don't actually exist, they're just potential, but at the same time, the monopoly is competing against these competitors, even if they're not real. So it's virtual competition, competition with potential competitors that keeps monopolies from charging particularly high prices. So that's where a very important point is that monopolies tend to act like monopolies in the case that they feel protected. Right? That is, where they're reasonably confident that entrants are not going to enter. As long as there is the threat of entry, that can often be enough to keep a monopoly from being able to charge a high price. They'll charge a low price to prevent that entry from happening. So, in the end, do we really need to worry about monopolies and competition? Well, it depends. Right? If we believe that the monopolies are protected, then they might act like monopolies and charge high prices. If we think they're always under the threat from new firms entering to compete with them, then we don't necessarily need to worry as much about them, as they have an incentive to keep prices relatively low.